So when we're looking at writing formulas, we're going to be looking at ions. And ions is a term that we've been using primarily in the previous units. And we know that an ion is an atom that has lost or gained an electron. Therefore, why did it lose those? It lost or gained an electron to achieve a complete valence shell, going back to that octet rule. So for example, you can see ions formation. You can see that Al3 plus means that it's lost 3 electrons. O with a 2 minus, you can see that it's gained 2 electrons. So when we deal with these ions, we know that there's 2 types of ions. We know we have cations, which are positively charged ions, or we have anions, which are negatively charged ions. Remember, negative means that you gained an electron, positive means that you lost an electron. So dealing with ions, we also have what's called a polyatomic ion. Polyatomic ions are ions that are made of more than one atom, hence the prefix poly. Poly means more than 2. Okay, or 2 or more, and then atomic or atom. So we have these that are found on table E. The ion is held together by covalent bonds, but is resulted as an ionic compound. So these are actually all ions and considered ions in ionic bonding. However, they are covalently bonded. You can see that they have a charge, so you can see how many electrons extra they have. So if you have hydronium, hydronium actually has a +1 charge. You can see that NH4 has a +1 charge. You can see that CO3 has a 2 minus charge. So really what this is that these, when dealing with compounds, they will give up an electron, give up 2 electrons, give up an electron, or gain 2 electrons, or gain 1 electron, so on and so forth. So it's not really that they have extra electrons, but it's how they are going, what they're going to do with the electrons that they have. So to look at this, when we deal with ionic compounds remember, are dealing with a metal and a non-metal. So when we're dealing with a metal and a non-metal, you always write the cation first. This is typically going to be your metal. Okay, when you're dealing with a cation, you write that first along with its possible charge. The overall charge of the compound in general must be 0, which goes back to the conservation of energy. So what you're going to do is you're going to use the overall ratio in the lowest form. And what you need to do, if you need to add more polyatomic ions, you have to put it in parentheses. So it's just like in math class, if you have something in parentheses like x and y, that means that x and y are together in a group. If I put a subscript here of 2, that means I have 2 xy's. Otherwise, just add a subscript as needed. What we like to do here is the crisscross method. So you determine the charge of your cation, and you determine the most likely charge of your anion. Using your reference table, this is going to be the uppermost in the list. Most of these you're going to notice have multiple charges. If there is multiple charges, use the first one first and see for the balancing. We're going to learn a little bit later on based off from naming. We're going to know exactly what that charge is so we don't have to guess. So we have Ca2 plus and we have Cl with a 1 minus. And what you're going to do is you're just going to take the charge of your anion and make it the quantity of your cation. And vice versa that, you're going to take the charge of your cation and make that the quantity of your anion. So when you look at this, you can now see that CaCl2 is your neutral compound. Kind of check your answer. We know that this is a 2 plus here. And we know that this is a 1 minus. So what you can do is you can take quantity times charge, which is 2, quantity times charge, which is a -2, and this should always equal 0. So 2 minus 2, we know equals 0. When you find the charge of an ion, it's from a group on the periodic table. Okay, so we know our little cheat sheet. We said group 1 is +1, group 2 is +2, 3 is +3, 13 is +3, 14 is ±4, 15 is -3, 16 is -2, 17 is -1, and then 18, which is 0. Polyatomics you find right on table E, and that tells you the charge there. And then we know elements that form multiple ions, we're going to use what's called a Roman numeral. And we're going to get to that when we do more of the naming part. So opposite of that, what we're going to deal with is covalent. So I like to use the word co. We talked about like a co-pilot. That means that you have multiple things. Well, what are those multiple things doing? Well, they're contributing based off from the count. So covalent is based off from prefixes. Prefixes identify the amount of each atom present. So we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. when you're writing these formulas, it's really important that you use the prefixes. Okay, so we're looking at tri. Trichloride means that there's 3 chlorines. Phosphorus is your first. If it's singular, you don't have to put mono. If it's the second one, though, however, you do have to put mono, just to be specific, like carbon monoxide. Carbon monoxide is CO. Carbon monoxide, 1 oxygen. So in this case, I have phosphorus, tetrachloride. Okay, just change the IDE ending of your second element, and there's your phosphorus trichloride. So I want you to practice some of these. We'll do the first one together. So I have lithium fluoride. Okay, lithium is going to be Li. What's the only ion possibility? Is going to be positive. Fluorine is going to be a negative charge. So the ionic formula, once you crisscross for those, is just going to be Li and F. Looking at molecular compounds. Okay, molecular, remember, molecular is the word that we can use for identifying a covalent compound. Okay, we have molecules, but molecular states that it is covalently bonded. So when we look at the molecular formula, we know it's carbon, and then it's tetra, meaning 4 iodine. So we have I, and we have 4 of them. So molecular compounds, you're just based off from quantity, where ionic compounds were based off from charge. And the easiest way to remember that is co. Co is a prefix for 2. And then ionic, which we're going to get into later, I is the Roman numeral 1, which we're going to talk about with charges. So, naming compounds. Just to summarize the naming of compounds, we have 2 types, ionic versus covalent. Ionic, you name the cation first, the anion second, changing that to an IDE ending. If you have a polyatomic ion, you name the cation first, the polyatomic ion second, as long as it acts as the anion. You're going to see that there are polyatomic ions that act as the cation. Okay, when you name these, you just name them straight off from table E. Don't change the name, no nothing. So this is actually a sulfate group, and you put the sulfate as and write it just as sulfate. So you have magnesium, sulfate. Now what we're going to do later on is we're going to use Roman numerals. So Roman numerals indicate the charge on a metal. They're used for metals that have more than one possible charge. So in this case, I have my cation, which is nickel, and I have my anion, which is a nitrate, which I found on table E. However, I need to determine the charge. So to determine the charge, you can actually uncrisscross this. The 2 goes up here. And the charge of the nitrate you can actually find on table E. And you know that that's going to be a -1 charge. By uncrisscrossing this, now it makes it easier to name. So I said that it's nickel 2 because that's the charge nitrate. Again, ionic bonds are all based off from charges. When we're dealing with covalent bonds are still based off from quantities. The quantities make this much easier. Students usually don't struggle so much with covalent bonds. So what you're going to do is you're going to name the first one, name the second one, make sure the prefixes are equated towards the quantities, and change the ending on the second atom as IDE. You can drop the mono prefix if on the first atom only, if that is indeed the case. So for example, we have nitrogen dioxide. Nitrogen, I have only 1. Di means 2 oxygens. Diphosphorus pentaoxide, 2 phosphorus, so P2. Pentaoxide, oxygen, penta meaning 5, so I have 5 oxygens. So when naming compounds, it's always important to identify the type of compound first. So when you're looking at NaBr, you need to identify the compound. So since I have sodium, I know that this is indeed going to be an ionic compound. Since it's an ionic compound, I know I'm naming it based off from charges. However, since my cation of sodium only has 1 charge, I don't really need to denote it. So since I have NaBr, I know that this is actually just going to be sodium bromide. So I put my IDE ending on bromine, making it bromide. So sodium bromide. Looking at the second example, I need to identify the type of compound, so I know that this is actually going to be covalent because of them being both nonmetals. Now I need to name these. Naming covalent, remember, is based off from quantity. So I have monobromine boron, but I don't need to put the mono, so I can just put boron. And then I have 3 fluorines, so I know that that is going to be tri. And then this is going to be fluoride. Again, changing my ID ending. Tri telling me there's 3, so always go back. So 1 boron, 3 fluorines, BF3. Perfect. So now looking at number 3, identify the type of compound, which I know is going to be ionic. See if aluminum has multiple charges, which it does not. The only possible charge is a 3+. If I uncrisscross that, you can see that this is a 3+, this is a 2-. Now I need to name it. So I have aluminum. And since there's only one possible charge, I do not need to denote it. And then I write my anion, which is just oxygen, which changes into ox, I-D, oxide. Now looking at number 4. Number 4 is still going to be ionic, okay, because we're looking at the base molecule here. So let's name the base first, and then we'll deal with the hydrate second. So I have copper SO4. This looks like a polyatomic. So looking at that polyatomic, I got to look at table E. Looking at table E, I know that that's a sulfate. Okay, so I'm going to put my sulfate down there. I'm going to name this one a little bit backwards. So I know that's a sulfate. So now I need to determine what the charge of the copper is. So since it's at a 1-to-1 relationship, table E tells me the charge of sulfate is a 2-. So if it's a 1-to-1, 2 minus 1, because remember this is in parentheses, so there's just a 1 outside there, it's a 2-. I need to figure out what this is going to be times x. So you can solve it algebraically or just think about it for a second. So I have x times 1, which is x. I know that this has to equal 0. So x minus 2 equals 0. I know that has to be a positive 2. So I know the charge on my copper is a 2+. Now I can just name it as seen on table S. So I have copper 2 sulfate. And now I need to name my hydrate. So I know I'm just going to name that off from the number. So I know that 5 is penta, like a pentagon. Penta, and then just name it hydrate. So overall, you have copper 2 sulfate pentahydrate. And that is your answer for that question. I'm going to let you do the rest on your own. Remember to always identify the type of compound first, and that determines the type of name or naming system you're going to follow. Remember, ionic, I in ionic stands for Roman numerals. Co and covalent stands for quantities. So ionic is always based off of charge, where covalent